as in maybe later on today. 5, 4, 3, 2, 1, here we go. Okay, last two examples. These will carry you through the rest of your worksheet. Right now we're scheduled to test on Thursday when you return from Thanksgiving. And tomorrow I will hand to you your study guide. That way, in case you want to get started over Thanksgiving, you can. Okay? All right. It says, write an equation for a polynomial that has solutions of 4 and I. Notice what we've given you so far is we've said, say, P of x is equal to x cubed minus 2x squared plus x minus 5. We've said, take that and find the solutions, right? Well, now we're saying, forget it. We're not going to give you the equation. We're going to give you the answers, and you find the polynomial. Now, there's something wrong with this setup right here. It says it has solutions of 4 and I. Is it ever possible to have one imaginary solution? They always come in pairs. So therefore, if I is a solution, so is negative I. Very good. So I have 4, I have I, and I have negative I. The second part of the fundamental theorem of algebra told us, like the most important part was that degree tells us the number of solutions. But the second part says x minus, right? X minus 4. And x minus I. And x minus negative I, which I could write as x plus I. So the fundamental theorem of algebra says if we multiply this out, we're going to come out with the polynomial that has those solutions. You tell me, would you rather multiply, say, the x minus 4 times the x minus I, or would you rather multiply the x minus I and x plus I? Everybody agree we want to multiply the imaginaries together? Also notice that, what do we call these two things? They are conjugates, which means the middle will cancel. So see the beauty and how that's going to work out. So let's focus here first, okay? I've got x minus 4 times, multiply it, what do we get? X squared. Okay, you've already canceled the i's. I'm just going to show it. Plus xi minus xi. Right? And then I got a minus I squared. Very good. So the conversation is now that we have an x squared. Our xi's gone. What is I squared? Negative 1. And then because it's minus, it will be good. So notice what happened. Your answer should never have any i's in it. They will always go away, and you'll be left with a nice behaving polynomial. Can we now multiply this out? X times x squared. X times 1. Negative 4 times x squared. Negative 4 times 1. So I have this polynomial is of the form x cubed minus 4x squared plus x minus 4. So it's actually true that if you wanted to check your answers, you could take all of your solutions and write them in factored form and then multiply them all back out. You're shaking your head right now. That's a lot of work, right? I think we're showing other ways to kind of verify and check your answer as well, right? So hopefully we don't have to go that far, but that's the idea. Ready for the last one? Okay, so write an equation for polynomial solutions of negative 3 and 4 minus 2i roots of 3. Okay, getting the furrow eyebrow look right now, okay? Can an imaginary solution ever be by itself? No. No, they always have to come in. So therefore, what's my other one? 4 plus 2i roots of 3. What do we call those? They are conjugates. Very good. So this is where it gets just a little bit dicey, and please be patient. Let's take our time. If negative 3 is a solution, I'm going to have x plus 3. This is the point I was trying to make yesterday. I know I wrote it as x plus 3 because you know it's x minus negative 3, right? Well, don't take shortcuts when you get to that. X minus 4 plus 2i roots of 3 and x minus 4 minus 2i roots of 3. Can everybody see how some students would switch one of the subtraction signs to a plus sign by accident? Most commonly made mistake in that situation. Please show good discretion there. So x plus 3, I'm going to distribute my subtraction sign. X minus 4 minus 2i roots of 3. What's the next one going to be? Yes? Good. Looks kind of disgusting. But the nice thing is we already talked about what should happen to all the i's. It should cancel if we do this right. Let's leave the x plus 3 here, and let's just go through the dirty work of multiplying that whole thing there. Ugly. All right, so we're going to start with the x's, x squared, so I'm starting with this term. What comes next? Minus 4x, so x times negative 4, and then x times this guy. So I got x times this guy's going to be 2xi roots of 3. Never written that before, have you? Yep, so we'll just, we'll write that and just take that in, okay? Remember, it's got an I on it, so it should disappear. So don't worry about trying to keep track of that. But I just got done with the x. We're going to move on to the negative 4, and I will get minus 4x. Yep, good. Negative 4, negative 4. I got positive 16. Good. I'm done with the negative 4? Yeah. Okay. Minus 2xi roots of 3. What's negative 2i roots of 3 times negative 4? 8i roots of 3. What's 8i roots of 3? And then we've got minus 4i roots of 3. Close. So when we multiply these two together, the negative 2 times the positive 2, I've got negative 4, and I got I times I squared, and then root of 3 times root of 3.
Wait, why does that work? Oh, wait. Okay.
So if you look here, as I multiply those all out, I get negative 4 I squared times 3. What's I squared?
Negative 1.
Times negative 4?
Positive 4.
Times 3?
7.
That's all right. It's okay. We just decided to do addition. There's a lot of addition signs up there too. Looks bad? Let's make it look pretty. What cancels? Yeah, so Jack says 2xi roots of 3 and negative 2xi roots of 3. Those are gone. Braden, what else is gone? I thought I took your answer. Yeah, negative 8i roots of 3 and positive 8i roots of 3. That kind of cleans things up a bit, doesn't it?
Oh, wait.
So I've got the x plus 3, and what I have here is x squared minus 8x
Negative 4x minus 4x.
and plus 28. That looks nice. What happened to all the i's? They went away. Let's finish this off. We now multiply these two together. We start with the x. X cubed. Then move on to the 3x squared minus 24x. 84, Randy Moss. 2 of you got that. X cubed minus 5x squared plus 4x plus 84. That's our polynomial. Okay, now